Good morning, students of physics, and welcome to this video section of the simple harmonic motion series. Now, if you have not subscribed to this channel, click on that subscribe button there, and then click on that notification bell so that you'll be notified when we post the next video in the series. Now, welcome. We want to look at this question. Remember, in the previous video, we solved a question on the topic. So we are advancing in the topic now. Now, look at this question. It says, a body performing simple harmonic motion has a frequency of 50 Hz and an amplitude of 10 centimeters. All right. Now, we are to calculate maximum velocity, maximum acceleration, velocity at the center of the path of oscillation, acceleration at the extreme of the path of oscillation, velocity and acceleration at a distance of 6 cm from the center of the path of oscillation. Now, let's quickly solve this question. I hope you still have your formulas copied from video 1 of the series. Okay, so let's solve now. The question says, a body performing simple harmonic motion has a frequency of 50 Hz and amplitude of 10 cm. So the way we're going to put it now is, we're going to write down our data. Frequency is 50 Hz. Okay? Amplitude is 10 cm. And like I told you, anything that you have in cm, change it to meters by dividing it by 100. Now we have that's 10 over 100, which is 0.1 meter. Take note of that. Okay, so now the first question says we are supposed to find the maximum velocity. If you check the formulas I gave you, you will see maximum velocity there. And peradventure it is not there. The formula is maximum velocity is Vmax, okay, is equal to omega A. And you know what omega is from the first video. And if you look at the data here, we don't have omega or W. That means we have to find it. How do we find it? Pick a formula that has, for omega, that has F. Use this one. W is 2 pi F. Because we have F, now we have, so W will now be 2 times pi is 3.142. F is what? 50, right? If you multiply all these things, what do you get? This is 100, you get 314.2. The unit is radians per second. So now that I have found W, my Vmax, which is maximum velocity, will now be W is 314.2 times A. Our A is 0.1. If you multiply it now, you get 31.42 meters per second. So take note of that. That's maximum velocity. Now, maximum acceleration. Number 2 says you should find maximum acceleration, right? The formula for maximum acceleration is A max. The formula is negative omega squared A. Okay? Negative omega squared A. How do you do that? This minus here, you don't use it in the calculations. The minus shows that the acceleration is directed towards the center of oscillation. That's all it signifies. So you don't use it in the calculation. It shows that the acceleration is directed towards the center of oscillation. So if I want to now solve my A max, that's maximum acceleration. I have our W is 314.2. Our A is 0.1. There is square here, so I put square here. So use your calculator and multiply it. Let's see what we get. we will have 314.2 squared multiplied by 0.1. It gives me 9872.164. So it gives me 9872.164. The unit is meters per second squared, and that's our E max. Now, very quickly, we look at number 3. Now, please pay very good attention. Very important. Number 3 now says we should find velocity at the center. And if you check those formulas I gave you, at the center, once you hear at the center, your x is equal to 0. Check your formulas. It's among those formulas that I gave you. And if our x is 0, and you're supposed to find velocity at the center, velocity at the center, once you hear that at the center, the formula is w root a squared minus x squared. We have to use the formula that has x because x is given now. So if we substitute, we already have w. So our v will now be, our w is 314.2 square root of a is 0.1 minus x is 0. Remember, at the center, x is 0. If I now solve this, I have 314.2 times square root of 0.01. This 0.1 squared is 0.01. 0 squared means nothing, so throw it away. And we have v will be 314.2 times square root of 0.01 is 0.1. If you now multiply the two, you have this time this is 31.42 meters per second. That is our velocity at the center. So please take note. At the center, x is equal to 0. Then number 4 very quickly says we should find the acceleration at the extreme. At the extreme means end. X is equal to a. So please take note of that. X is equal to a. A means amplitude. So we are using the formula acceleration. Acceleration is equal to, since x is involved, use that formula negative omega squared x. I've told you before that negative does not, you don't use it in calculation. It shows that the acceleration is directed towards the center of oscillation. So for us to now solve it, we have, what's our W? 314.2. Our x is now a, and our a is 0.1. So it means times squared is here, times 0.1. If you now solve it, you get the same answer we got before. 9872.164 meters per second squared. Are we following? So please at the extreme know what to do. X is equal to a. Then finally, the final part says E. Acceleration, velocity and acceleration at a distance of 6 cm from the center. Now, anytime you hear something from the center, or now you have 6 cm from center, it means that x is 6 cm. Anything from center is your x. So change your cm to meter. We have 6/100, which is 0.06 meter. Don't forget, anything from center is x. Now, we are looking for the velocity at this center here. So you're going to use omega root a squared minus x squared. Please know when to use this formula. You only use it if x is given. Anytime x is given, use this formula for your velocity. Now we have Our omega is 3.142. Sorry, 314.2. Square root of a is 0.1 squared minus 0.06 squared, because x is 0.06. Okay, so now we have 314.2. 0.1 squared is 0.01. 0.06 squared, 0.06 squared is 0.0036. So if you now subtract, you have 0.1 minus 0.01 minus, okay, 0.01 minus 0 will give us 0.0064. So we now have, we need to get the square root of 0.0064. Square root of 0.0064 is 0.08. Are we good? If you now multiply this by this, you get your final answer. So multiplied by 314.2, it gives me 25.136. So 25.136 meters per second. Don't forget, anything you solve for, put the unit. All the units I gave it in video 1. So anyone you solve, put the unit. Then finally, we are looking for the acceleration at that distance x. So the acceleration will be negative omega squared x. Take note of this formula because s is involved. So I'm not using minus to solve it. I've told you before. Now w is 314.2 squared times x is what? Our x is now 0.06. So 0. If you multiply that out on calculator, you have 314.2 times 0.06 will give me 18.852. So I have 18.852 meters per second squared. So these units I'm putting here, all of them are in video 1. Anything you solve for, put the unit. Okay, so this is the end of this video. In the next video, I'll still solve 1 or 2 questions so we can round off the series. Don't forget to hit the subscribe button so that when we post the next video, you'll be notified. Thank you for coming around.